We've now got a solid way of combining for of loops with generators to do some basic iteration through a custom object, especially when we are using the iterator symbol as well. But we're still at kind of a loss of finding a practical example of all this. When would we use this in practicality? So this time around, we're going to put together a solution for a for of loop to iterate through a tree data structure. So let's take a look at a diagram of a tree. So trees are a very popular data structure that can be used in a variety of different purposes. Trees organize data in a series of nodes. There's a parent node or root node at the very top, and then each child of this node can have some additional children. So the very root node we have has 3 children. The one on the far left over here has 2 of its own. The one on the far right has a single child, and that one has 3 of its own as well. So we've got a tree data structure right here. Now you might be thinking, Stephen, when do we use trees in web development, right? When do we ever see those? And I'm going to counter that. I'm going to challenge you there. I'm going to say that trees are everywhere in web applications. Let's pull up a very practical example of a tree. I'm going to pull up the very popular, really tremendously popular website, reddit.com. So reddit.com allows people to have just arbitrary discussion on any type of topic you could possibly imagine. I'm looking at a single post right here that is on a picture of the sun. I'm going to scroll down a little bit to the comments section. Every comment in here, there is a root comment. So this is like the parent one right here. And then it has some number of child comments. And so it looks like this parent comment has a single child. And then that child has a collection of children. And then those children have their own children as well. So this is, we can just keep on expanding more and more. So the comments section on reddit.com can really be thought of as a collection of different trees. There's the collection of top level comments that I'm collapsing right now. And each of these trees has its own collection of sub nodes, each one representing a comment through and through. So what I'm trying to communicate here is that in practice, we do end up seeing trees a lot in web development. So perhaps it would be really useful to figure out some reasonable way of creating a tree and then iterating through it. So a practical use case of this might be like, say, find all the users who have posted on a given thread. To do so, we might iterate through all the list of comments and find the authors of each one and say, okay, who are the authors on this thread? So I'm going to say that we should create a tree data structure, and we'll just make it an arbitrarily sized one. And then we should use symbol.iterator to iterate through it. And then once we can iterate through it, we can do any type of operation on the tree that we would want to possibly do. We can look up for a particular node. We could collect all the different values in there. Anything you might imagine we could do once we can iterate through it. So step 1 here is going to be to create a tree data structure. We're going to use a ES6 class to serve as a blueprint for each individual node. So again, we're going to create a node. Each node will have some amount of content. So we're going to pretend that this tree that we're creating here is going to represent a series of comments. So each node will have some amount of content and will have a reference or an array of children. So let's give this a shot. I don't really want to focus quite so much on like the tree aspect of this as the iteration and the use of generators. So we're going to kind of go through the tree implementation a little bit quickly here. I'll create a class of comment, and then we'll define the constructor. And the constructor will take some value and an array of children. Then this dot content, and you know what, I don't really want value here, I apologize, I really want content. So this dot content will come from content, and this dot children will come from the list of children. Now I can create an array of children by doing something like new comment. And we'll say good comment, bad comment, and just meh. And then we'll create one parent node to house all these 3 children right here. So we'll say const tree is a new comment, and its children will be that array of children that we just created. So we've got the root node right here. It has 3 children. And then those 3 children don't have any children of their own, but we could easily add more in here if we so chose. And so if we looked back at the diagram, we've kind of got a data structure right now that just looks like this top portion. We've got the parent node, and then it has 3 children of its own. And each node has a value or some amount of content associated with it. We could print out the tree really quick, and then we can see that the root node is right here. So it has content of great post and then an array of children. So definitely we've got the tree right now. So that's the tree. That's the easy part here, relatively easy. So now we need to figure out a way to iterate through this data structure. So we could write out a generator function again and call, pass in the tree and then call a yield on each child, blah, 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 that kind of stuff. But we need to assume that our tree is going to be of arbitrary depth here, right? If we think about the approach that we took in the last section when we were iterating through the teams, we only had a setup there to kind of go like 1 level deep, right? We had like the primary team, the engineering team, and then we had the test team as well. And so we just went from the primary team, the engineering team, just to the test. There was only 1 level of iteration. We need to make sure that we recurse through this tree and we climb down, starting at the top node, all the way down to some child at some arbitrary depth down here. So let's continue in the next section where we will figure out how to combine the symbol.iterator along with some level or degree of iteration. So I'll catch you in the next section.